So the big picture of this lesson is linear functions. And here I have a linear function graph. And a linear function gets its name because it looks like a line. And a linear function also has a constant rate of change. So the slope is constant. And that's what makes it look like a line. So here's one representation. I have a graph right here, and notice that there are arrows on both ends. That means that it continues in both directions forever. Another way to represent a linear function is an equation, and one way is slope-intercept form. That's usually the first way you learn about these things. Y equals mx plus b, where m is the slope and b is the y-intercept. So for this function over here, y equals, now to find the slope m, it's rise over run. So it looks like up 3 and right 2 is the pattern. So 3 halves. And the y-intercept looks like it's at 1, 2, 3. So my equation is 3 halves x plus 3 in this case. Okay, now a linear function, or any function for that matter, can be written in function notation, and that looks like this. Okay, so instead of y, you have f of x. And so that is basically saying function of x is 3 halves x plus 3. It means the exact same thing as y, it's just fancy math notation. So f of x is the output, x is the input. So what if I want to evaluate the function? What if I want to know y for x equals 2? Well, what I can do is I can read it off the graph, or I can input 2 into the function. Either way, let's do the input first. So I want to know f of 2. And I know that looks a little weird, but basically you're saying you want to know the function of 2. So you're inputting 2 for the x. This f of 2 is basically saying I want to know the y value for x equals 2. So that equals, well, 3 halves times 2, you can do 2 over 1 here, and you can do 6 halves, which is basically 3, so it's going to be 3 plus 3. F of 2 equals 6. So that means y equals 6 when x equals 2, basically. So let's go over to the graph and verify. Here's my x equals 2, and then go up till I hit the line. Yep, that's 6. So let's clear this off, and then we'll talk about another feature of functions. Okay, now if you're looking at a function graph, you can tell a function because of a vertical line test. Let me just draw a squiggle here for a function. So let's go like this, then like that, then like that. So how do I know if that's a function or not? Just put arrows so it keeps going. Well, you have a function if for every input there's exactly one output. And my favorite analogy is for cooking something. Like you put all the ingredients in the pot and you should have something at the end. In other words, if you're making chicken soup, you put all the ingredients in for chicken soup and you get chicken soup. It never works out where you put all the ingredients for chicken soup and then you get a huge cake. You know, something like that just doesn't work. So that's an example of a function. Whatever you put in every time, you know what's coming out every time. And you can test that with a vertical line test on a graph. So basically, anywhere I draw a vertical line, if you can imagine a vertical line, like here's one here. See, it only hits the graph in one place, right? And if I draw another one here, same thing, it hits the graph in one place. So what you want to do is kind of mentally move across the graph with vertical lines and see if you have a problem. In this case, there is no problem. What if you have a graph like this? Well, I think it's pretty clear in this case that you don't have a function because if you draw a vertical line here, basically anywhere along the function, you're going to hit in two places. So there are two outputs for an input. This is not a function. So there is a mathematical word for this also, besides saying it's not a function. You can just call it a relation. Okay, so those are the big picture items for this lesson. You have linear function is a constant rate of change, how to use that to evaluate a function, and then the vertical line test can visually check whether a graph is a function or not.